All right, so this is fitting a line of data or just scatter plots, however you want to look at it. It's all basically the same thing. And this is 10D, which means we only have 2 sections left in the year. Pretty sweet. All right, so let's start with our objective, shall we? Will be to find a linear function that describes the line of best fit in a scatter plot. To assess the fit of a function by plotting and analyzing the residuals with the use of technology. Now, that one's going to be more done tomorrow in class, but that is one of the objectives for this particular section. And then decide which type of function is appropriate to represent a data set. What I'm going to do with this one is calculator tomorrow, okay? And in the video, we're going to show you how to do it by hand. So right now, by hand. And that's important to know because it's easy to forget the button sequences and everything on the calculator. If you know what to do, you can just do your basic things on the calculator by hand without any problems. So, and also will be to solve problems by using a function appropriately fitted to the data set. So some vocabulary, you really only have 2. Scatterplot. It's a graph used to determine whether there is a relationship between paired data, or correlation. So correlation means relationship. Line of best fit, and that's the line that most closely follows a trend in the data. All right, so let's take a look at the first example. Table below, this one right here, shows a body length and wingspan, both in inches, of 7 birds. And we want to find an equation that models the wingspan as a function of body length. So this is it in table form, and this is what we call a scatter plot. So basically we have 1521, and if we go there, that's right about there. Okay, so this isn't exactly the scale, but this is pretty close. So we would say, okay, that's 1521 right there. 1944 is right about there. 2147, you know. So it's kind of, you get the idea. So what we would do is first we would find 2 points that we can use to draw a line of best fit. So now I picked the first and the last just because it happens to work out. It's not always going to be the first and the last because you want your line, this is my line here, to go through and look. There's 4 points on the line, 2 below, 1 above. It should be pretty evenly distributed around that line. That's what we call line of best fit. And this one is done by eyeballing it. Tomorrow I'm going to show you how to do it on the calculator and let that do all the work for you. But at any rate, for this one, picked the first and the last. Okay, and then we're going to use the slope formula to determine, we're going to use those points to determine the slope using the slope formula. So remember that was y2 minus y1 over x2 minus x1. Okay, so 67, because this was one of the points we used, was that 2667, and this point was 810. So we did 67 minus 10, and then 26 minus 8. So since I did the 67 first, I had to start with the 26, which gave me 57 over 18, which reduced, or not reduced, but when you divide 57 by 18, you get 3.17. So that's our slope. So now to determine the y-intercept, you pick another point that's on that line. So this is one point that was on the line. You could have actually used any of these points, but I chose the smallest one for obvious reasons. At least I think it's obvious. So replace. Okay, now remember, slope-intercept form, that's the one in here. Let me get rid of this. That looks like, y equals mx plus b. So we figured out our slope was 3.17. And what we needed to find now is our b. Okay, to do that, we're going to take that 810, replace x and y with the 8 and the 10, as you can see I did here. So 10 equals 3.17 times 8 plus b. So when you do 3.17 times 8, you get 25.36 plus b, and subtract 25.36 from both sides, and you get negative 15.36. So now we have our b. We have our slope and our b, so your answer is y equals 3.17x, which is right here, okay, minus 15.36, because it's negative 15.36. Next example. Table below shows the number of DVD rentals from a particular video store from 2008 to 2011, and they give you the equation that models that. Okay, and Now, keep in mind here, X is the number of years after 2008. Okay, so predicted number of DVD rentals in 2012. So it's not, we don't put, like, for 2009, we wouldn't put 2009 in for X. We would put 1, because that's 1 year after 2008. If it was 2010, we would put 2, because it's 2 years after 2008. But they're asking for 2012 for us to predict the number of DVD rentals in 2012, which isn't shown from the data on the table. So what we do is say, well, 2012 is 4 years after 2008, so use 4 for X, solve for Y. So Y equals negative 0.3 times 4 plus 2.45, which is negative 1.2 plus 2.45, which is just 1.25. So in 2012, the number of DVD rentals will be 1,550, because notice this says in the thousands. So it wouldn't be 1.25, and actually it should be 1,250. Okay, so because this is in thousands, so we take that and multiply it by 1,000 because of this. Not every time, just by whatever number it says in the chart. Okay. Last example. Match the model with the scatter plot. So one of these scatter plots is a quadratic. One is linear decreasing. One is shows exponential growth. And one shows no correlation, meaning there's no relationship between the X and the Y values. So if you had to guess, take a guess in your head. And then basically everything shifted down one. No correlation, because look, all of these points are all over the place. Quadratic. We've got that nice curve going to it, right? Okay, that's not pretty, but you get the idea. It's quadratic. Linear decreasing, if we were to draw a line of best fit, pretty much right through there. And exponential growth, notice it has a slight curve upward. Okay, so that should be easy for you. You should be really, really good at this one. Alright, so for next class, you're going to learn how to use a calculator to do a lot of this, not all of it, and it's not going to be the end-all be-all. It'll probably be more confusing than anything, so hopefully you picked up on this. It's still important to know how to do it without one. I've mentioned that a few times. And there's only 2 sections left, so good job. I really like how you guys are finishing out the year, so I'm really, really proud of you. So good job, and I will see you next class.